Well, students, today let's have discussion about different kinds of materials and their chemical reactions. The chapter number 4 of your textbook. So here we are going to classify all the elements into metals, non-metals, and metalloids. Till today, we have about 114 elements known to us, and as you have understood in previous classes that we have different kinds of materials, pure substances, compounds, mixers, and all that things. The pure substance may be elements or compounds. The things around us, you know that all the plants, animals, human beings, they are all made up of chemical elements. And these elements, based on their properties to conduct heat and electricity, they can be classified into metals, non-metals, and metalloids. So, elements, all elements, they are the substances that are made of only one type of atoms. And if the substances are made of different types of atoms in their combination, then they are called compounds. So elements, these 114 elements, we are going to classify them based on their property to conduct electricity or heat. So these metals, non-metals, non-metalloids, and their properties, their physical properties and their chemical reactions they can undergo, we are going to study in this chapter. So about the physical properties of the elements, here let's have this one. The physical properties of the metals, non-metals. Let's compare their physical properties. We know that most of the metals, they are hard, and the non-metals, in comparison to them, they're soft and brittle. Generally, all metals are hard, but there are few exceptions that some of the metals, they are soft and small liquid at room temperature. For example, sodium metal. Sodium metal is soft enough to be able to cut with a knife. And another metal, that is mercury, which is used in the thermometer, they are liquid at room temperature. So, with few exceptions, other metals, most of the metals, they are very, very hard. Can I assume that? And the metals are soft and brittle. And another property of the metals is that they are malleable. The malleable means it is a property by virtue of which a metal or a substance can be beaten into thin sheets with a hammer. So, when hammered, if a substance can be beaten into thin sheets, then there can be a metal. That is, that property of being able to be beaten into thin sheets with a hammer is called malleability. And so, most of the metals can be beaten into thin sheets, so they are malleable. That is, metals are malleable. Here, metals malleable and non-metals, they are not malleable. That is, they cannot be beaten into thin sheets. Then another property is ductility. Ductility is the property that substance can be drawn into thin wires, into long thin wires. And the metals, they have this property of ductility. So the metals are said to be ductile because they can be drawn into thin wires. And non-metals, they are not ductile. They cannot be drawn into thin wires. Non-metals, you know the examples: non-metals, hydrogen, sulfur, oxygen, etc. They are example of non-metals. And copper, silver, gold, they are example metals, and they can be thrown into thin wires. They are malleable. They can be beaten into thin sheets. They are hot. These are the properties of the metals. And then now we have the conductivity. That is, the metals, they are very good conductors of electricity and heat. That is, they conduct electricity, and so that we in the home we light electricity using electrical wires. The electrical wires, they are metals which are very good conductors. They are made usually of copper metal. And the metals, the bad conductors, they cannot conduct electricity. And this conductivity of electricity can be demonstrated using a simple circuit of the lighting the bulb. Say, for example, at home you can do this, taking this piece of wire and a small bulb, a torchlight bulb, and a battery, torchlight battery, and the substances you want to test. Here, this one, this piece of substance can be anything of metal or plastics or other non-metals. So this circuit diagram, here we have the bulb. Here, this is the battery, and this is the piece of material that you want to test, and this is the wire, metal wire, which conduct electricity. So here, if you take a piece of copper or aluminum or any other metal, then when you switch on the system, then this light bulb will glow, indicating that this is a metal and a good conductor of electricity. Whenever you use metal like silver, gold, aluminum, copper, seed, etc., then this light bulb will glow because this is a metal and can conduct electricity. Then if you replace this with a piece of plastic or paper or a wooden stick, and then you switch on the circuit, and this light bulb won't glow at all because this is a very bad conductor and it cannot complete the circuit, cannot pass the electricity through this piece of substance, which is a non-metal. So when you use non-metal in this circuit, this light bulb won't glow. That is, non-metals do not conduct electricity. So here, discussing further, we have another property of metal, that is lusterness. Lusterness means a newly cut surface of any metal, they are shiny. That is, the shine when you scratch metal or cut metal or polish a metal with something like steel wool or sandpaper, they will show lusterness. That is, the surface of metal becomes shiny due to the scratching or rubbing or cutting of the surface. So that property of shiny, that property metals show is called lusterness. That is, metals are luster. Metals have lusterness. They are lustrous. And non-metals, on the other hand, they do not show any luster. That is, there is no lusterness in non-metals. Whenever you cut the surface of non-metal, you cut the paper, you cut a wooden piece of plastic, they don't show any lusterness on the surface or on the cut area. So, in short, we can say that metals are lustrous and non-metals are not. And then we have sonorosity. That is, metals are sonorous. That is, whenever you beat or strike a metal, when you strike a metal, they will produce a ringing sound. That is the property of producing ringing sound whenever you struck a surface or metal or a piece of metal is said to be sonorous. That is, metals are sonorous. They can produce a ringing sound, but non-metals cannot produce any ringing sound. That is, whenever you struck a surface of wood, etc., it will produce a sound like oh, no ringing sound is there. And when you strike a metal surface like the iron or anything made of metal, any utensils you can use, when you struck it, it will produce a etc. like that. That is, they produce a ringing sound. There is a ringing tone in there. So these are the properties that we can discuss about the say about the metals and non-metals. That is, metals and non-metals have these distinct properties. Then after this, let's come to the chemical properties of metals and non-metals with different substances. Here, first, let's have a reaction with oxygen. Metals, reaction of oxygen with metals, reaction of oxygen with non-metals. Here, in the first example, we have reaction with oxygen of metals. That is, for example, let's take here magnesium as an example. Magnesium, when you burn magnesium in the presence of air, that is, the magnesium will burn in the air with a dazzling flame, with a very bright flame, producing magnesium oxide. Here, this is magnesium oxide produced after burning this magnesium in air, in the presence of air. That is, magnesium combines with dioxygen, producing magnesium oxide. Then what is the property? What property can this magnesium oxide show? So this is a white flaky substance produced after burning this magnesium. This magnesium, you ignite it with the matchstick, so with the burning matchstick, then it will burn in the presence of this oxygen and produce a white flaky substance, magnesium oxide. And this magnesium oxide, if you dissolve in a little water, you put in a glass, you take some water, put this magnesium oxide and stir it briskly, then you get this magnesium hydroxide. And this magnesium hydroxide can be tested using a litmus paper. You take a red litmus paper and dip into this solution. Then the color of that litmus paper will change to blue, indicating that this magnesium hydroxide is basic in nature. That is, this magnesium oxide, after dissolution in water and testing with the litmus paper, so that the solution is basic in nature. This magnesium oxide, as it is dry, it is in solid form, you cannot test it with litmus paper. So in order to test this, you dissolve in the water and test with that red litmus paper, and so that it changes to blue coloration, and that shows that this magnesium hydroxide is basic. That means magnesium oxide, the metal oxide, is basic in nature. That is, whenever you react a metal with oxygen, they will produce their oxide. That is, metal reacts with oxygen, producing their metal oxides. And that is, most of the metal react with oxygen, but some may not react, like silver, gold, etc. They may not react with oxygen, but most of the metals react with oxygen, and their oxides, their metal oxides, are basic in nature. Then now let's react that oxygen with a non-metal. But when non-metal reacts with oxygen, they produce acetic oxide, just opposite of that of metal. That is, nonmetals produce acidic oxide, whereas metal produce basic oxide. This is, for example, when you burn sulfur. Sulfur is non-metal, you know that. Sulfur, in the presence of oxygen, they will produce sulfur dioxide. And you dissolve the sulfur dioxide in water and test it with the blue litmus paper. What will happen? The blue litmus paper will change to red, indicating that the non-metal oxide produced there is acidic in nature. That is, from this we can understand that metals form their metal oxide when reacted with oxygen, and that metal oxide is basic in nature. And non-metals, on the other hand, reacts with the oxygen, producing acidic oxides. That is, non-metal oxides are acidic. And now let's come to another reaction with water. And here, reaction with water, most of the metals some metals react with water very vigorously, like sodium. Here, sodium metals react with water vigorously, producing sodium hydroxide and hydrogen gas. The reaction is so vigorous and produce a lot of heat energy that the hydrogen gas produced here will catch fire. This hydrogen gas will catch fire due to the heat produced during the reaction. The reaction is so fast and so vigorous that the hydrogen produced catches fire. There is some of the material reacts with water very vigorously, and some may react slowly and some may not react at all, like silver, gold, copper. They do not react with water, and some iron, etc., they react slowly, very, very slowly. And on the other hand, non-metals do not react with water. The non-metals do not react with water, but some metals react with water vigorously, some react very slowly, and some may not react at all. Then after this, reaction with dilute mineral acids means dilute HCl, dilute sulfuric acid. That is the aqueous solution, that is the acid, mineral acid mixed with water, dilute acids. They react with metals, but their reactivity may be different. Here, for example, zinc can react with dilute sulfuric acid. Zinc Zn can react with dilute sulfuric acid, that is H2SO4, producing zinc sulfate, that is salt of zinc, and hydrogen gas is evolved. That is, metals can react with dilute mineral acids, producing hydrogen gas. And non-metals that do not react with acids, with mineral acids, they do not react with acids. And then again, after this, reaction with base. Reaction with base, some metals may react, for example, some dilute solution of strong base like sodium hydroxide may react with metal, and reaction of non-metals, they are very complex, they're complicated reactions, and that won't be discussed in your class. That will be discussed in the higher classes. And after this, another reaction is about the displacement reaction. It is the displacement reaction, that is the replacing of one metal by another from their salt solution. Here, for example, copper sulfate. This is copper sulfate CuSO4, copper sulfate, and the reaction copper sulfate and iron. Here in this reaction, iron is more reactive than this copper. In the reactivity series, or that is, the iron is more reactive than copper. So here we have taken copper sulfate salt, and iron as metal. And when you mix this together, this iron can displace the copper from copper sulfate and can produce iron sulfate. And the copper in copper sulfate is being reduced to pure copper. That is, as the reactivity of iron is higher than that of copper, copper will be displaced. This copper will be kicked out, will be displaced by this iron, and that iron will combine with that sulfate fort, producing iron sulfate. Here copper is reduced to copper. Copper in copper sulfate is being reduced to copper, and is being combined with the sulfate for producing iron sulfate. That is called displacement. Here copper is being displaced by iron, the more reactive one. And if you reverse reaction, that is when you combine ferrous sulfate, that is iron sulfate, with copper, there will be no reaction because copper is less reactive than iron. So this copper cannot displace iron from its solution. From its salt, iron from its salt cannot be displaced by copper. Copper cannot replace the iron sulfate. So there is no reaction in this when you mix iron sulfate with copper. But if you mix copper sulfate with iron, iron will displace copper from its copper sulfate solution or from its copper sulfate compound, and will produce iron sulfate, and copper and copper sulfate will be reduced to copper. That is, for example, you take say a test tube, then put inside that copper sulfate solution, which is bluish in color. This copper sulfate, we have taken this copper sulfate, this is bluish in color. That is, write it like this, bluish. And we put iron nail inside this is the iron nail, this is the copper sulfate solution with bluish in color, and you wait. After some time, what happens is that the solution becomes greenish in color due to the formation of iron sulfate. Copper sulfate is bluish in color. It is in the previous test tube, and after waiting some time, the solution inside the test tube becomes greenish in color due to the formation of iron sulfate. That is, the iron in the nail get dissolved and combined combined with the sulfate. That is, copper is displaced from its solution and forming itself iron sulfate. That is, the iron from the nail goes to the solution, combined with the sulfate fort, and produce iron sulfate, and the solution becomes greenish. And the iron nail itself becomes reddish brown in color. This iron nail becomes reddish brown in color due to the deposition of reddish brown in color due to the deposition of copper metal on the surface of the nail. That is, in this reaction, copper sulfate combines with the iron from the iron nail and forms iron sulfate. And copper sulfate goes to the iron nail and deposited there, making the iron nail reddish brown in color. And the solution becomes greenish in color due to the change of copper sulfate to ferrous sulfate. That is, due to displacement reaction, the copper from copper sulfate is being displaced and it reflects with iron, forming iron sulfate. So in this way we have different types of reaction, and different types of chemical reaction can be produced when you react matter with many substances like oxygen, dilute acids. They can also undergo displacement reaction, and non-metals may or may not react with some of these substances. That is, non-metal also react with oxygen, and like they can also, but they do not react with acids, etc. So with this, we completed this discussion about the types of reaction that metals and non-metals can undergo, and different properties of metals and non-metals. In brief, we have discussed about this. So you also read hard after listening to this. You read the book again and again and try to understand all that is written in the book. And with that, we will wind up discussion of this chapter. So next time let us discuss another chapter of this book, and that's all for today. Okay, thank you very much.